Okay, so slope-intercept form. Okay, so slope-intercept form, we know, y equals mx plus b. In slope-intercept form, what does the m stand for? The slope, good. Okay, what's the b stand for? Y-intercept, good. Okay, so when we start with the slope-intercept form equation that we want to graph, we're going to end up using the same strategy that we always use, which is to plot 2 points and then connect and extend those points to make the line, only we're going to tailor those 2 points to the information that's given to us, right? So there's our y-intercept. M stands for the slope, as we said. Here's a summary of our strategy for graphing equations in slope-intercept form, and this is just what it looks like in your textbook too. First of all, we want to, if it's not already in slope-intercept form, we want to put it in slope-intercept form. And what that means, by the way, is I'm just going to isolate y. If I'm given a linear equation and I solve for y, get the y by itself on one side, and I collect like terms and all that stuff, I automatically end up with y equals mx plus b form. So if we're not already there, we have the option of solving for y to get there. Okay, once I've got it in slope-intercept form, then here's my strategy. Now we said we want to have 2 points, plot 2 points, and then connect and extend. Well, we're given 1 point to begin with, right? We're given the y-intercept. We know where the line crosses the y-axis, so we'll call that our anchor point. That's our first point. We'll plot that. To get the second point, what do you suppose we do? What else are we given? What other information are we given about this line? Wait, the slope. Okay, could we use the slope to get a second point?
Yes.
Sure. We'll just use a slope triangle to get a second point, and then all we do is connect and extend. Okay, and we're done. Let's look at an example. Very simple. So let's take this guy. Y equals 3/4 x minus 2. What's the slope? 3/4. What's the y-intercept? -2. And it's already in slope-intercept form, right? So where's our anchor point going to be? Where's our first point? -2. Okay. So there it is. It's a little bit off. I don't know why it's off a little bit. It should be down just a little bit. But you get the idea. So there's 1 point. To get the second point, we're just going to make a slope triangle, right? Now they do it okay, but I like to do it using rise over run. So I like to do the vertical part first. So if the slope is 3/4, slope is rise over run, what's the rise going to be?
3.
+3, good.
Is that in my calculator?
Oh, I don't know. What color?
Gray.
I haven't seen, it would have been in the classroom, you think?
Yeah, I left it while doing my PSAT.
Oh my gosh, I haven't seen one. But you know what, I bet you if you did, they would have taken it, whoever was in here probably would have taken it. Yeah, the opposite. Try that, yeah. Okay, so we're gonna start at this point then, and we're gonna rise by 3. Right? And then what's my run?
Go over by 4.
4, okay. So we're gonna go this way, 4, and then there would be my second point. Then I just connect and extend. Okay, make sense?
Mm-hmm.
Now notice what they do on the PowerPoint, and this is the way it's going to be on the one I put online too. They draw a slope triangle. I just don't like the way they do it. They draw horizontally first. Gets you to the same place though, right? So there's our second point, connect and extend, and we got it. Okay, make sense? All right. Standard form. Standard form is a little different. I don't know, you've seen this, but you may not have a lot of experience using linear equations in standard form. Now, instead of y equals mx plus b, this is standard form. Ax plus by equals c. Now, the a and the b and the c are capital here, and what that's to remind you of is that they can't be fractions. They need to be, if it's written in standard form, they need to be integers, which is convenient. Why would we do this, you might ask? And you probably ask that a lot in math. We do things different ways, and it seems like sometimes probably from your perspective, like, why don't we just settle on one way and do it that way? Well, it turns out that standard form is important to us because, as we'll see in the next unit, when we solve systems of linear equations, not just one of them, but if we have systems of multiple linear equations and we want to find the solutions of the system, I'm going to show you some really good tricks that use a calculator that allow us to solve really big linear systems that would normally take us hours to do in just like 10 seconds on a calculator. So, but to do that, they need to be written in standard form. So more about that later, but standard form does end up being important to us. Okay, so what about this then? If we've got a linear equation in standard form, what's our strategy? Now we want to remember, we want to just find 2 points and then connect and extend. Okay, well as it turns out, 2 of the easiest points to find are the intercepts, the x and y intercepts. Now if I want to find, for example, let's take the y-intercept. What can you tell me about what's going on at the y-intercept? It's where the line crosses the y-axis. But do you know one of the 2 coordinates at the y-intercept?
Sure.
Yeah, what's 0? You're right. The x-coordinate is 0, isn't it? Every point on the y-axis has an x-coordinate of 0. The y-coordinate is going to vary, of course, but the x-coordinate is always 0. That's important. What about the x-intercept? The y-coordinate of every point on the x-axis is 0, and therefore the y-coordinate of the x-intercept must also be 0. That's a great trick for us. So what we end up doing then is we find the x and y intercepts and just connect and extend to create the line. There's a great little trick for doing this. Yeah, I guess here's a summary of the steps. We're going to put it into standard form if it's not already in standard form. Then we'll find the x-intercepts by letting y equal 0. Okay. Find the y-intercept by letting x equal 0. And it doesn't matter which order you do those 2 steps in, and then connect and extend. Okay, let's take an example. There's a little trick you can do. So what about this one? 2x plus 3y equals 12. Now if I want to find the y-intercept, let's say, we do that by letting x equal 0, because you told me, right, that the y-intercept is on the y-axis, and so the x-coordinate must be 0. Now what's going to happen if I let x equal 0 in this equation?
12 by 3, you get y.
Okay, that's going to be y, isn't it? Because if I let x equal 0, 2 times 0 is 0. So here's the trick. We call it the cover-up trick, or the cover-up method. If I'm finding the y-intercept, if it's in standard form, when I let x equal 0, the x term just disappears. So I just cover it up. Cover up the x term and solve for y. How about that? And then that's a one-step equation. I just divide both sides by 3 and get an answer of, once again, 4. Okay? They do y first. I don't know if they do y first or x first. They don't get it the other way. So if I want to find the x-intercept, I do the opposite, right? I'm going to let y equal 0, which makes the y term disappear, so I just cover up the y term and solve for x. So our strategy, if it's in standard form, is to find the intercepts. Literally, cover up x to find the y-intercept, cover up y to find the x-intercept. Okay, so if I cover up the y term, what's x equal to if I solve? 6, sure. So I get x equals 6, there's our x-intercept. When I covered up x to solve for y, I got 4, so the y-intercept is at 0, 4. There's the y-intercept. Right there. Connect and extend. Piece of cake. Piece of cake. Okay, so, one other issue, yeah. This is a good time to talk about this real briefly. Horizontal and vertical lines. Now, if I look at let's look at a horizontal line. Y equals mx plus b. What's the slope of a horizontal line? What's the slope of a horizontal line? Now think of it as a rise over run, right? We know that slope is rise over run. How much does a horizontal line rise between points? 0. Yeah. So no matter what, the top of that fraction is always going to be 0. The run could be anything. It doesn't matter. If I run by 10 or 20 or 1,000, it doesn't matter. 0 divided by a number is equal to what? 0. So therefore, the slope of a horizontal line we always know is going to be 0, isn't it? Right? And so what do we get from this equation then? If the line is horizontal, if m is 0, 0 times x is always going to be 0. And so I end up with something like y equals a number. We could call it b, we could call it a, we could call it anything. But if y equals a constant number, we know that's a horizontal line because the slope must have been 0, right? Yeah, that's no big deal. Now what about a vertical line though? If I have a vertical line, yeah, we get troubles there, don't we? If I have a vertical line, this time the rise isn't 0, the run is. Now can we divide by 0? No, that's one of the two things with real numbers that we can't do. We can't divide by 0. And so that means that the slope, we would say, is undefined. You can't give a number answer for the slope. Okay, so vertical lines don't have slopes, they're undefined, and so what do I do with my slope-intercept form? It blows up, it doesn't work, right? I can't use slope-intercept form to define a vertical line because the slope is undefined. So what I've got to do instead is I've got to use standard form. Okay. And so here's what we get. Horizontal lines, we already said, look like y equals excuse me, some number, call it c if you want to, that's fine, just some number. And they have a y-intercept, of course, then of 0, c. They're horizontal, they have the same y value everywhere. The one we're most concerned about is the y value on the y-axis. You know, where do they cross the y-axis? So it's at c. Now, vertical lines are the opposite. With vertical lines, they don't have a slope, but they're going to have the same x value every place, aren't they? Right? The y value is going to change, but the x value is always going to be the same if the points line up vertically. And so their name is going to be something like x equals some number, some constant number. Okay? Let's look at just a couple examples. So what if you wanted to graph y equals 3? Here's how you can remember this. If I see a line that looks like either y equals a number, a constant, or x equals a number, a constant, you automatically know you're talking horizontal and vertical stuff here, right? These are not slanted lines. They're horizontal or vertical. Which one is which? Well, if it's a y equals a number, that's telling you where that line cuts through the y-axis. If it's cutting through the y-axis, it must be horizontal, right? So y equals 3, you're going to look like this. Okay? It's cutting through the y-axis at 3, which makes it horizontal. The line x equals -2, if it's cutting through the x-axis perpendicularly at -2, that makes it vertical. Make sense? So it's easy to remember those. Those are kind of the simple cases of lines. Okay, last thing I want to take a very quick look at is just a Moodle example. And then we'll get out of here. And you'll see how easy this is. Whoops. Okay, so what if we look at one like, how about one like this? Easily done, you're right. Okay, so if we're trying to, now in Moodle what you're going to do, instead of actually graphing it, you're just going to identify the graph, which in a way is even easier. What's the slope here? 2. Okay, so m equals 2, and what's the y-intercept?
-3.
Okay, so now think about this logically. If I'm hunting down the graph with those characteristics, what's probably the first thing I'm going to look for? Narrow it down to what?
-3.
Yeah, the y-intercepts of all the graphs with y-intercepts of -3. And then of those, I'll just try a slope triangle on each one and see which one gives me a slope of 2. right? So then I end up with, if I go through these, let me make this just a little bigger. Well, you guys can see that okay, can't you?
Yeah.
Okay, so if I want to find y-intercepts of, what'd I say, -3?
Yeah.
Yeah.
See.
Oops. Then let's see. Okay, let's see. That's -3 right there, but the slope's wrong, right? The slope's not 2. That one's no good. No good. We're looking for -3, right? That's -2, so that's not going to work. There's an example right there. Okay, what about that one?
Yeah.
Let's grab that one. Okay, so there's my y-intercept at -3. Let's do a slope triangle. What was the slope supposed to be? 2. So if I go up 2 and over 1, it doesn't work. This one goes up 3 and over 1. So that's not it. Okay, the slope is wrong. But I would have to just find the one that goes up 2 and over 1 to get back on the line. Does that make sense? Okay? What if I had, I'll make this quick. You want to get down and work on this stuff. What if I had let's say I had a problem like this. Tell me what my strategy would be on Moodle if I was given 2x minus 3y equals 6. Standard form. How am I going to try to identify which graph it is? What do you think?
Put 0 in at y.
Okay, so that's going to give me an x-intercept of what? 3. So I'm going to get to point 3, 0. Put in 0 for x, and I'm going to get a y-intercept of.
-2.
And then I just look for the graph with those intercepts, right?
Easy enough.
Easy enough? Yes, sir.
How is it negative then?
Because if I cover up the x, if -3y equals 6, I got to divide both sides by -3. 6 divided by -3 is -2. Got it?
Or also, you can, what you can do.
Whoa.
Not over.
True. That's right.